Okay, let's keep this factoring train a-moving. X squared minus 49. That looks like another difference of two squares. So, can I think of two numbers that multiply to give me 49? That's a perfect square? Sure, 7 and 7. And then x squared, that's x times x. So we can factor this one into x plus 7 times x minus 7. Okay? Remember, one thing to notice here that we're doing these factoring problems here, a lot of students feel like they have to solve for x. Remember, there's a difference between factoring expressions versus solving quadratic equations. Notice that there is no equal signs on either 9 or 10, and if we go back here, look at 7 and 8, no equal signs there either. So, no equal signs, no solving, so there is no solution for x. We are just trying to write a factored form for it. So if we look at number 10 right here, that's another one of those big three. Can you come up with two numbers that when we multiply them together we get positive 48? And those same two numbers add up to 14. I think we can do it. X times x is x squared. 48. I'm going to do it wrong on purpose the first time so that way we know that that check is valuable. So 48, I think 24 times 2 is 48. Great. So I must have the right answer, right? Wrong! No, we don't. Once again, it's the oi part of FOIL. If we do the oi, we have 2x combined with 24x. Those like terms, 2x and 24x, combined together to give us 26x. Not the one that we're looking for. We are looking for 14x. So all that means is that we just have to use a different pair of numbers here besides 24 and 2. Let's see here. Something's telling me that 6 times 8 might be the one we need to use here. Let's check it. FOIL, first is done, last is done. 6x and 8x does add up to 14x, so we have successfully factored that one. Let's keep going. Ooh, these are the fun ones here. Now, do you see what makes number 11 different from number 7? Number 7, a 4, an 8, a 60. We had a greatest common factor here of 4. In fact, negative 4 that we could take out of here. What makes 11 different? We have a 2, a 9, and a 10. Okay? So, Mr. Cook is going to show you each one of these, and I'll put them in different colors here. So in blue, this is one way you can do this, factoring it by grouping. Here's how you do it. Take that 2, multiply it by 10. So what you are now looking for are two numbers whose product is actually 20, and their sum is still that middle number of 9. So I can think of two numbers that do that. I think it's 5 times 4. And also 5 plus 4 would give us 9. Now when you think about that 9x that's right there, think about that 9x I'm just going to put right here, and we could rewrite 9x as 5x plus 4x. So we can rewrite this whole trinomial, one with 3 terms, is quadratic, and let's rewrite it as an unsimplified quadratic with 4 terms. So 2x squared plus 5x plus 4x plus 10. Keep the 10 there, not the 20. And now we're going to factor this thing by grouping. To factor it by grouping, what you're going to do is group up the first two, and you remember me in class using brackets? I like to use brackets, so that way it reminds me to not accidentally FOIL this. Okay? If I accidentally FOIL this, I might say another accidental F word that I probably don't want to utter here on this helpful educational video. Okay? So, now that I've grouped these two up, let's look for some more GCFs. And we're going to do GCFs on each one of these two groups. So 2x squared and 5x. The only thing I can really factor out of that would be an x. And then I'll put some parentheses in. If I factor an x out, now I'm left with 2x plus 5. Over here, 4x plus 10. I think I can factor out a 2, right? A positive 2. And here's a great way to know if you're doing it right. Once you've completely factored out the 2 and correctly factored out the 2, take a look at what I have left in the parentheses. In the parentheses, I have a quantity that's exactly the same as this quantity right here. So what we actually do here next is we look at the fact that we have two terms here separated by the plus sign, and these two terms here actually have a common factor that we can factor out. Kind of like GCF work. And so then we have 2x plus 5 and then look at what's left here is x plus 2. Okay, and now we've successfully factored it, didn't we? Couldn't we check this answer once again by foiling this, right? First times first, 2x times x, 2x squared. Last times last, 5 times 2 gives us the 10. Now it's time. 2x times 2 gives us 4x. 5 times x gives us 5x. 4x and 5x, 9x. Done deal. Okay? Now what about that guessing and checking method? I'll write the exact same thing over here. 2x squared plus 9x plus 10. You can guess and check your way there by using a little bit of logic. We know that if we're experts at foiling, first times first needs to give us 2x squared. Because 2 is prime, I'm stuck having to do 2x times x. That's the only way it can go. Now with 10 I have options. Here's a bad option. Let me choose 10 and 1. 10 times 1 makes 10, but do you see that when I do 10x and 2x, 10x plus 2x makes 12x, not 9x. So then what I could do logically is maybe reverse those. If I put a 1 and then a 10 right there, try it again. 20x plus 1x gives me 21x. Still no good. See how I'm guessing and checking here. What if I tried a 5 and then a 2 and then checked? First should be good. The last should be good. Once again, it's the 5x and the 4x combined to give us the 9x. So you can guess and check your way there on the factoring. Pretty slick, right? Right. So I don't care which way you do it. Okay? Either one of these two ways is fine with me.